In this video we'll be looking at proofs. Proofs in maths come in a few different forms. It links well into the topic of forming your own equations. We use descriptions provided and have to convert them into equations and then solve them to prove a statement. That's more so to do with the higher level questions. But we also have other questions that you may be expected to do at foundation, such as these two here. So we need to prove there is a factor of 48 between 15 and 20. Now, just by listing the factors of 48, although it might not seem obvious at first, you get 1 and 48, 2 and 24, 3 and 16. The list will go on, but we can see here that 16 is a factor between 15 and 20. So therefore we have proven that statement. Similarly, we need to disprove that 10 is prime. So you think to yourself, what does it mean for a number to be prime? For something to be prime, its only factors are 1 and itself. So if 10 is prime, the only factors of 10 are 1 and 10. But we know because 2 and 5 are also factors of 10, we can say, therefore 10 is not a prime, and we've disproved the statement. So it's very important to have maybe a little sentence at the end of these questions, just to reiterate that you've understood what they're asking you. So, moving on to something a little bit harder. This is again pushing the level 5, 6, 7 plus area. When you get a situation like this, we need to prove that the left-hand side is equal to the right-hand side. You might have seen this kind of thing when I explained my video on identities, where we have this triple equals here. It just means for every value of x, no matter what it is, this will always be true. So, when you look at a question like this, we're looking out for something that you can manipulate in some way. Whether it's expanding brackets, simplifying down terms, or anything like that. You can see straight away we have brackets to expand on the left-hand side, so we're going to do exactly that. So we'll keep the 3 on the outside here, but if we expand x plus 2 squared, we're going to have x squared plus 4x plus 4. And again, if you aren't too sure on that, I've made a video on expanding double brackets, so go ahead and watch that back. And then the second one will expand out to become 3x squared plus 12. Now also, I have kept the brackets here. This is because the minus affects both the 3x squared and the 12. If that negative wasn't there, you might forget that it affects the 12 as well. So it's very important to keep that. And then if we write the right hand side as well, just to remind ourselves throughout each step. Now if we factorise this first bracket, we can see that 3 is going to come into it, make it 3x squared plus 12x plus 12 minus 3x squared plus 12 equals 12x. Now you can see straight away we've got 3x squared minus 3x squared and 12 minus 12. That leaves us with 12x equals 12x. And hence that's our final statement proven. Okay, the next kind is a little bit harder. We don't have anything explicit, and we need to form our equation ourselves this time. The sum of 3 consecutive odd numbers is 27. This bit here, you may not be familiar how to turn what is an odd number into algebra terms. So if you think about your numbers, let's start with the even numbers. That will be the easiest to do. Your even numbers are 2, 4, 6, 8, 10, so on. If you look at all those numbers, all of them are multiples of 2. That means if we call our even numbers 2n, for any value of n, for example, if n is 1, that would equal 2. If n is 3, that would equal 6. You can see they form even numbers. So 2n is what we want to call our even numbers. Now that we know that, what would we call our odd numbers? So odd numbers, think about how the numbers go. We start with odd at 1, then we go to an even, then odd, then even, then odd, then even, and so on. Now if our even numbers are 2n, our odd numbers always come before or after those even numbers. So we can say our odd numbers are 2n plus 1, or 2n minus 1. So you start with the even number, and you plus or minus 1, and that will get you guaranteed an odd number every time. So that's really important here. So The sum of 3 consecutive odd numbers is 27. Find the largest one. So we know that our first odd number could be 2n plus 1. Our next odd number from that, let's say this number was 3. The next odd number is 5. You can see that we've added 2. So we're going to have to add 2 more to that. So 2n plus 3. And finally 2n plus 5 equals 27. Now all we do is just collect up the terms. So 6n and plus 1 plus 3 and plus 5 is 9. If we subtract 9 from both sides, we're going to be left with 18. So n must be 3. It's asked us here to find the largest of the numbers. That is going to be this one here. We've worked out that n is 3, so if we substitute that back in, we can see that 2 times 3 is 6, add the 5, that's 11. And that's our answer done. Okay, one more question. I came across this the other day, and this is more aimed at the level 8-9 candidates. Prove x to the power of 64 minus 1 is not prime. Now you may go through certain scenarios in your head trying to work out what this is, how it would work. Think about what, again, back to similar to the first question, what makes a number prime? If something is prime, it has, the only factors it has are itself and 1. So to disprove this, we need to show that this has factors, or it can be factorized. Now some of you may look at this, most of you may look at this, and you think you can't factorize that in any easy way. There's no x's in both, there's no numbers in both. Have a look, this number and this number, they are technically both square numbers with a subtract in between. Now, I haven't personally made a video on this yet, but there will be one in the near future. This is something called the difference of 2 squares. If you've got 2 square numbers with a negative in the middle, you can write them in this form. X to the 32 plus 1 and x to the 32 minus 1. And because this is technically factors of the original, because these two multiply together to make this expression, this means that it is not prime because it has other factors. The whole way this works, again, I will explain in depth in another video, but when you were to expand it out using the double clause, just like the maths we used for the double expansion, the x term in the middle will cancel out because of the plus and the minus 1. So you're just left with the x to the 64 minus 1. And that is our final answer. Thank you very much for watching, and I hope that helped.